Oh, okay, hold on. Let me get the desk cleared off real quick here. And there we go. Oh boy, I'm so excited to work on this thing. All right, this thing is now fully operational. Um, I didn't get any footage during the repair because I was fighting for my life, but I put together like a little montage reenactment, so I hope you enjoy that. Alright, so if you're trying to fix one of these, I have all the panels removed here. Things pretty well degreased, cleaned off. I'm going to try to point out some common issues, at least that I've run into, seen other people run into, and then try to just, I don't know, get as much footage of this thing as I can, because trying to fix it, it's impossible to figure out, like, just by looking at it, what's supposed to happen. So I'm going to go through those here. Okay, so if you're trying to work on this thing and this lever is stuck down, it's usually because this right here was pressed down. This is it's pretty easy to hit this one. It's basically, there's barely any spring tension at all. This is the clear return button. So this thing is going to be trying to shift to its home position, which is either going to be to the right. If this is selected, it'll go this way. If this one is selected, it'll go to the left. But up here, this is where this is a little linkage back here. It has two little nubs, one on the left, one on the right. But if I turn this on now, this is what it's going to be doing. So it's just frantically trying to get to where it needs to go. If this is stuck, or something's going on where this is not getting hit, it's just going to keep doing this. This is going to stay down. Everything's going to be locked. So all you have to do is just right here, just pull that up. That's going to whatever signal that it's been shifted all the way, and then that's how you get this lever to release. Okay, so this is the keyboard kind of selector area that's right below the keyboard wheels. I've removed the actual button columns here. And these are these are surprisingly easy to take out. And honestly, all these things do is they just have that rack that selects how far the hook on the front goes, which is going to mesh with each of these little nubs right here. So when I push on this, like that, the number gets selected. So this is all just a proportional thing. It's how far forward it's being pushed. I didn't have any issues with this, like pushing not far enough or like in between two numbers and getting locked up that way. But you can see, at least it's easier to see this with the keyboards removed. These little tiny, each of these number wheels has an associated like stepped cam thing down there. It's not quite a lead-nut screw because it's selecting what levers are going to mesh with the transmission selection. So again, really complicated in there. But if these things are sticky, it's probably not this shaft. I mean, there is this shaft, and these number wheels might be, stuck to the shaft. But there's another shaft. It's the same diameter for these teeny tiny little wheels down here. And that one is a little screw on the side. So I'm going to try to point out what this angle is. All right. Yep. Okay. So right here, if you remove this screw and the washer, this is the shaft, and it's got a little notch in it. It's held in by the washer. I didn't have to remove this all the way, but I did just kind of work it back and forth, twist it around, and that was ultimately what was causing the keyboard stickiness issues with mine, or especially if these things are moving with each other, like if you move one number like this and then this one starts to move. I had that happening with like honestly most of them. It was like 6 out of the 10 were stuck together. That's usually a shaft issue where they're stuck to the shaft. So there's this shaft, there's that shaft. I mean, there's just a whole lot of stuff down here. I can show a bottom view in a second, but that's the view from the underneath the number wheels for the keyboard. Okay, so I'm just gonna have it do like an addition here. I'm gonna try to do it by hand so I can show all the different timing and like when things start moving, which parts are supposed to move. You get this from this view. I'm gonna try to get one from underneath as well because the setting shaft, which is way down under there, is impossible to see from this angle. Okay, so just hitting the button, got a lot of movement, a lot of these levers, and it's impossible to see when they move because it's not one continuous movement like on most machines where you have one cycle where you have one revolution and then that's it. So how I'm going to do this is I'm just going to turn it off and do it by hand. So I'm going to press the button down. So all that's done is we have this kind of main thing that triggers the points. So there's the little contacts and it's moved the little thing back. Let me focus this. So it's now the contacts are closed, so it's going to try to move. So I'm going to try to get a good shot of the control unit from the side here while I do this. So that is closed. We have this lever down. It's starting to select this. Sorry, this is going to take a while because it is. Okay. So far nothing's happened with any of these shafts in here. It's about to hear a click. There we go. Okay, so at this point the clutch here all the way through the reversing clutch to this shaft is connected. So I'm going to start turning this. Now we have that gear moving. And with that you have, this shaft down here, this one, not this one unless there's any key selected, and then this lower one. And all these are geared together, so it's not really that complicated, but I just keep doing this. So I'm going clockwise. There we go. So we had another click. This thing went 180 degrees to the top, and then there was a click, which I'll show where that's coming from in a second. It's down on the selector. And we keep going. And then you can feel a pretty good change in resistance during one of these. So now this is beginning to move back. And almost. Come on. And it's almost there. This takes a long time. Okay, so now it is finished. This is the operation is finished. So there's a lot of different movements in here. It wasn't just like, like a Monroe or something where, okay, you press the button and it spins around. I'm going to get a shot of this from the bottom as well so we can get the, what is that, the setting shaft, big giant greasy shaft running down the side there. So this is the setting shaft right here. Watch out for this clutch. It's the same as the main clutch at the top. It's like kind of vertically right above it. This one will get stuck just like that one. I wouldn't have known that was down here unless I was really looking for it. But if this does get stuck, this is supposed to, the shaft should be able to turn in its entirety counterclockwise, like I'm turning it now. But the little dogs will disengage if the shaft is moving clockwise. Just wanted to make sure that you guys see that. Anyway, I'm going to do an addition now. Try to get in here at this weird angle. But, okay, power's off. So I just press the button. Down. Let me get, where's the thing I use? There we go. So I'm actuating it, main clutch, that way. So the setting shaft immediately starts to move. We have this cam lobe that's pushing these little selector levers for the gears that go into that weird little cam looking thing. I should point it out underneath the keyboard wheels. But this thing goes about, I think it's 180 and then stops. Okay, so there was the click. So the larger shafts up here are now spinning, and the setting shaft should stop moving. Yep. Okay, so now the entire addition. Nope, that was halfway through. Now we have movement again on the setting shaft. So this thing moves 180 degrees, stops, and then moves again to finish. And oh, yeah, this is kind of, bear with me here. I'm trying to help anyone who's trying to fix this thing out because this is insanely complex down here. There it is. Okay, so the operation is now finished for addition. Okay, so in case you needed a view of the levers down here below where the operation pad is, I'm just going to do some things here. This is the little keyboard release. This is the lever that gets pushed down sometimes that does the return or clear return button I was talking about earlier. I'm going to do that here. So I'm going to do the thing, stop it, and it's finished. This spring right here, if you need to check what that's supposed to look like, it's a little torsion spring. It's right there, it's right there. This one fell off for me, and I was like, oh no, how does this go? I guess this is a good time for me to point out this gigantic spring right here, fairly long, and inside of this I found this guy. This thing. So it took me about probably 20 minutes to figure out how to pull this massive felt that had somehow worked its way into the spring, because this thing has a felt liner, which is, but Marchant being, a pretty the standard for mechanical calculators in the United States, they actually they thought this through, and they made these little rulers. It says silent speed on it, and you get your little felt guy, and you stick him up there. And the idea with this is that once this thing reaches 6 inches, it's time to get a new hobby. All right, so this shaft up here, this is the main clutch. This is the reversing clutch, and that is right there, if you can kind of see that. So in addition, this main clutch always spins clockwise. Do some additions there, and this goes like a half turn. And subtraction, this thing spins counterclockwise. Now with the main clutch, I had issues with this locking up. I had to lubricate this quite a bit. There's a couple little ratchets there, and they're spring loaded. You can kind of see the springs in between the gear and the whatever that is. The reversing clutch is a little more complicated. So this entire shaft is like packed. You can't see anything, especially on the backside. But if you're having troubles with this clutch, the reversing clutch, there's only one slot on this little plate here. And so the little dog that has to grab that like that, if this is not in the right spot, so when this is engaged for addition, this thing rotates. If this disengages for whatever reason, this thing's going to spin like this, and also this will be completely locked up. So if you're having trouble with that, I'm trying to get this thing rotated in a position so that you can get this back in there. Not sure how much more help I can give with that. This is just this one especially, a lot of issues with that. The main clutch, I've heard of people having to remove this from the machine to get it unstuck, but that's where those things are. Okay, so I had to unjam this thing I don't know how many times, but when it does jam, it's usually pretty violent, and it will immediately, for me at least, it just plumes of smoke just start billowing out of the motor. It's not a fun situation, but I was able to get it unjammed most of the time with these two shafts. This one right here, now you can see that. This is the setting shaft. The other end of it, this is on the underside. There's another clutch that is probably going to get stuck, so just be aware of that clutch being there. It's pretty similar to the main clutch. And I actually had to destroy this bracket to get this out of the other machine. This thing is very thick. A lot of things have to spin, covered in grease. Anyway, this thing is geared 14-to-1 from the main, motor shaft. So that's addition, that's subtraction. For me, what I did was every time this thing jammed right here, even when it was like sort of jammed, like kind of maybe not 100%, I wouldn't usually notice this shaft, but this shaft up here, which these are all connected to when you're doing addition or whatever in operation, got these two little grabby guys that grab that, and then this right here that basically prevents these from setting back down. These have to be in this position. If this is a little bit slightly rotated, you'll probably notice that these will be kind of stuck out. And that's a pretty good indication that there's something wrong. Sometimes I was able to get this thing rotated like this, just using a wrench. But most of the time, this setting shaft down here, being connected to the reverse one-way clutch deal here, a lot of times what I had to do is just get something like these pliers, get it stuck in there, and be able to get it kind of gingerly moved until it was in this position when I could spin this back. Depending on where the machine was supposed to sit, this notch, you can see the notch only goes a half turn each time, so it's not easy to just be able to tell, oh, this notch needs to be on the right or the left side, but eventually you can get it to where it will rest, and then it should be able to clear up those jams. Okay, so a lot of the shafts on this thing, including this one, which is, so this just fell apart on me, but this is this component right here. This is the only one that is uncovered, so you can see there's a little set screw in this, and what these are, like these little kind of oilers almost. And I'll kind of explain how that works here. So we have, I'll just go ahead and take this whole thing out. This is what that looks like, and it has a bunch of little holes on the sides. It's a little dirty, but like right there. And inside here, with the set screw removed, which I'm going to do, there we go. There's grease in there. Now when you get it, this thing's going to be full of cement. It's like a whole composite made of like rust and old dried up grease and whatever else. But if you can get that out, you can use the set screw to pressurize this and kind of squeeze grease out of it.
So they call this thing the silent speed because it's incredibly quiet.
Okay, so setting the motor RPM on this is pretty easy. I'm going to go through that real quick. This little screw back here is the governor speed adjustment. So you just turn that clockwise for speed up, counterclockwise, slow down. You can't do this by holding down the plus button, like I guess on most automatic machines, but you can time how long it takes to count to, let's say, 300. So if I have it divide 300 by 1, it's just going to count all the way to 300, and I can time that with a stopwatch. So I'm going to just add 300 divided by 1. And that's going to probably should have chosen a smaller number, but this is probably fine. All right. So that took, I guess, about 15.43 seconds. So 300 divided by 15.43 is 19.44 times 60 seconds. So that gets me at like 1166 RPM. So that's pretty close to the 1200 RPM set point. I feel like with these things, it's you buy this thing and you spend however many hours. I spent like 150 hours fixing this thing, and you probably want it to run as fast as it's supposed to. So that's how you do that. Check out how many decimal indicators this thing has. I've got these orange ones that slide around. I got the white ones that slide around on the carriage. Got all these down here, obviously. The orange ones are actually a like an option for doing reverse multiplication. So I'll put the link for the manual in the description here. But reverse multiplication, you can do forwards and backwards on this thing. So like if I have it set this way, which to me is normal direction, then I can multiply these starting with the largest digit. If I have it in the reverse direction, I can start with the smallest digit. I'm going to just go through what it would be like to do a normal direction multiplication, because that's what I usually do. Let's see, if I usually keep the decimal, like the standard true decimal, at like the middle. So that's going to correspond to this, and then I have this one up here for multiplication. So if I want to do 12.56 times 12.56, I would start in the tens digit up here, do 12.56, and there we go, 157.75 and some change. Okay, so most of the buttons on here are pretty self-explanatory. Once you figure out how to do the shifting and multiplication, I mean, that's all these are. That'll also control where this thing shifts. So if I have the tab stop, like right here, it'll go to this side. 3, it will go to 3, which is not very far. I keep it at 5 typically. These clear the counter accumulator, clears the keyboard. So the stop button for division, I mean, if you make a mistake, like I do a lot, and it's just going to do this forever, you know, that'll be bad for you. So the two things on here that I think are the most confusing are this lever and the reverse button. So I'll go over those. This lever right here is going to control what happens when it finishes a division. I think it's called the division clear return lever. So when it's pointing up, then when you divide something, so let's say 34 divided by 1.5, that, and then when it finishes, it doesn't do anything. So there's the answer. That's my remainder. So it didn't clear the remainder, it didn't move back to the tab stop. If I have this thing down, which is what I typically do, let's do, I don't know, 34 by 6.78. Okay, so that clears the accumulator. It returns home. The only thing it doesn't clear is the counter, but that'll clear again during the normal division. That just wants that. You can hit stop. That's to stop division. This will also turn off the reverse if you accidentally press it, is what the manual says. But this reverse button is for doing negative multiplication. So if I had, let's say 56, and I wanted to subtract 3 times 7, I would do this in reverse times 7. I would get 35. I think that's right. I didn't think that went through. That's probably right. But these will do the carriage shift, and I think that's pretty much all the operations. Alright, so it's hard to compare these two calculators just because this one has fully automatic multiplication where you have a multiplying register, and then this one has a little whatever, semi-automatic, on-the-fly, whatever you want to call it. But I can compare them doing automatic division because they have the same sequencing there. So I'm going to go ahead and have these things approximate pi by dividing 355 by 113. And this one's set to the 8th tab stop, so it's going to be the same as this one. So to put things in perspective, this is a Monroe CSA 10. It runs at 635 RPM, and this thing runs at 1200 RPM in theory. So this one should finish twice as fast as this. But I'm going to go ahead and demonstrate that here. And shaking the cable quite a bit. But they finished at exactly the same time, like literally exactly the same time. So despite all of the whatever fame, the silent speed, the fastest calculator ever made, all that, this thing has quite a bit of gearing and sequencing to where you're only really getting continuous 1200 RPM at some times. This thing is your simple little Monroe, Leibniz screw sequencing thing, and it's fine. This thing is ultimately, I think that Monroe pretty much beat out Marchant. This thing was incredibly hard to work on, and it looks cool when you have this thing go really fast, but, Monroe is still around. These guys are still making calculators, and I think it stands to reason that they never did anything too insanely complicated. This is pretty, this thing makes sense. This right here, this is an abomination that should never have been made.